Good evening, children.
Good evening, ma'am.
Good evening, ma'am. Good evening, children.
Good evening, ma'am.
Good evening.
Good evening, ma'am.
Good evening, children. Good evening. Kindly turn on your videos. So at the request of one student in the classroom, we are going to discuss the introduction to this chapter, polynomials. So we'll try to recall what we have understood from the videos. You may even write on this, whatever I write on the screen, you can even take it down in your book. So first, what is a monomial? What is a monomial? A monomial is a polynomial. A monomial is a polynomial with one non-zero term. One non-zero term. A polynomial with one non-zero term is called a monomial. Is called a monomial. A polynomial with one non-zero term is called a monomial. So examples could be, so see, 0, there's only one term, but it's a zero term. So 0 is not a monomial. 0 is not a monomial. 0 is not a monomial. Because by the definition, a polynomial with one non-zero term, one term, and that term should not be 0. One term, a polynomial with one term, and that term should not be 0. Should not be 0. A polynomial with only one non-zero term, it should not be 0, is called a monomial. So 0 is not a monomial. 0 is not a monomial. So examples of monomial. See, when we say monomial, it can be of any degree. When we say a monomial, it can be of any degree. We are not talking about the degree of the polynomial. Okay, so there should be only one term. The degree of the monomial can be anything. So examples can be, say, XYZ. XYZ is a monomial. XYZ is a monomial. What is the degree of this monomial, children? What is the degree of this monomial? X is raised to the power 1. Y is raised to the power 1. Z is raised to the power 1. So the degree of this monomial is 1 plus 1 plus 1, which is 3. So the degree of this monomial is 3. The degree is 3, but it's a monomial. Monomial meaning single term. Single term. This is only one term. And what are the variables involved in this term? X, Y, and Z are the variables involved in this term. This is only one term. And when one term has more than one variable, how do you find the degree? You should find the sum of the powers of the variables involved. You must find the sum of the powers of the variables involved. X, Y, Z is one term. It is a monomial. The degree of this monomial is, so this term has 3 variables, each of power 1. So 1 plus 1 plus 1, 3. The degree of this monomial is 3. So we can just write down that for your reference. You can write it down. So this is how you calculate the degree. The degree of this monomial is 3. Make a note. The degree of this monomial is 3. Please make a note.
Completed, ma'am.
The degree of this monomial is 3. You can just make a note of that. The degree is 3. Now consider the monomial a square, 5a square b, bc. All right, 5a square bc is also a monomial, is another example of a monomial. What is the degree of this monomial? So the variable, this is only one term. That's why it's called a monomial. So the variables are a square, meaning a, b, and c. So we have a square, b, c. The sum of the powers 2 plus 1 plus 1 is equal to 4. So the degree of this monomial is 4. The degree is 4. The degree of this monomial is 4. A, B, and C are the variables. A, B, and C are the variables. Their powers are 2, 1, and 1. Find the sum of the powers. The sum is 4. So the degree of this monomial is 4. 5 is the coefficient. Don't add 5. 5 is the coefficient. 5 is the coefficient of A square BC. You understand what to add? Do we understand what to add? You should add the powers of the variables involved. Yeah. Now, when we say x plus y, this is not a monomial. This is a binomial because there are two terms. The terms are separated by a plus or a minus sign. In an expression, the terms are separated by a plus or a minus sign. Plus minus sign separates the terms. So here there is a plus sign. So this x is one term, y is another term. But in xy is only one term. Because there is nothing between x and y. There is no plus or a minus sign between x and y. There is no plus or a minus sign between x and y. So xy is a monomial. But x plus y is a binomial. Binomial because x is one term, y is another term, two terms. Binomial. And how do you understand? How do you make out that these are two different terms? Because they're separated by the plus sign. The plus or the minus sign separates the terms. So this one is a binomial. Now to understand the degree of this binomial, the power of x is 1, the power of y is 1. You must consider each term. In this term, the power of the variable is 1. In this term, the power of the variable is 1. The highest power, here you should not add. Where you should add, you in one term, if there are many variables, in one term, when there are many variables, you must add the powers of the variables. So within the term, if there are many variables, you must add the powers of the variables. Now these are two different terms. So in this term, the power is 1. The power of the variable is 1. In this term, the power of the variable is 1. And the highest power is 1. So the degree of this binomial is 1. This is a binomial of degree 1. So monomial, binomial, trinomial. Degree is different. The number of terms in a polynomial, they are different. At the end of this discussion, it should be clear. Let me just go ahead. So I gave you the difference between x plus y and xy. Xy is only one term. XY is so if you have to say something about XY, you will say that XY is a monomial of degree 2. XY is a monomial of degree 2 is what you would say. But x plus y, say something about x plus y. If the question is say something about x plus y, what can we say about x plus y? X plus y is a binomial of degree 1. X plus y is a binomial, two terms, binomial of degree 1. So this is about monomial. The single term should not be 0. The single term should not be 0. Something other than 0, and there should be one term, and that term should be a polynomial. That term should be a polynomial. Now, for example, root of xy is an algebraic expression. Root xy is an algebraic expression. It's not a polynomial at all. It is not at all a polynomial. So it's not a monomial. It is not a monomial. Because why is it not a monomial? Because a monomial must be a polynomial. And what is a polynomial? The powers of the variable involved, the variable or the variables involved must be whole numbers. You must have got all this from the videos, children. It's very clear in the videos that A polynomial is an algebraic expression. A polynomial is an algebraic expression in which the variables involved have non-negative integral powers. Non-negative integral powers meaning whole numbers. A polynomial is an algebraic expression in which the variables involved have only non-negative integral powers. That means the powers of the variables involved are only whole numbers. The powers of the variables involved in the expression must only be whole numbers. Only then they are called polynomials. Otherwise, they are simply algebraic expressions. Otherwise, they are simply algebraic expressions. How many videos are on? Devadarshini, Sanjay Sindhu, always very, very good. Really, very good, Sanjay and Sindhu. So keep it on Krishmika, Shri, Devadarshini, no, I shouldn't talk about Sanjay and Sindhu. Madhumita, Lishant, Tanishka, Krishmi, Shri Jana, Netra. Pradit used to always keep his video on. Now I don't know why.
Yes, ma'am, I can't on my these days.
You need to fix your camera, is it?
Yes, ma'am. My PC gets heated up so that I can't view the screen then.
All right, children. So I was telling you that a polynomial is an algebraic expression in which the variables involved have only non-negative integral powers. Non-negative integral powers meaning the powers must be only whole numbers. So now when you consider this, when you look at this expression, okay? So this is x to the power half, y to the power half. Again, I'm not explaining this, you know that. This is in the radical form and this is the exponential form. X to the power half, y to the power half. X and y are variables. No doubt, x and y are variables. It looks like, okay, there's only one term, it's a monomial. No, a monomial must be a polynomial. See the definition. See the definition. A polynomial with one non-zero term. It should be a polynomial. So is root xy a polynomial? Let's understand. So root of xy is nothing but x to the power half, y to the power half. Look at the powers. Half. Is half a whole number? No. Half is not a whole number, and hence root of xy is not a polynomial. If it's not a polynomial, how can you call it a monomial? It is an algebraic expression. That's all. It's just an algebraic expression. So we need to be careful there. Just because, there is one, it looks like, there is only one term, you shouldn't immediately call it a monomial. There can be one term, but you must first understand if that is a polynomial, if that single thing given there is a polynomial. Everything is an algebraic expression. Everything made up of constants, variables, and mathematical operations. Any expression which is made up of constants, variables connected by, some or all mathematical operations are all algebraic expressions. But you should check if it's a polynomial. Check if it's a polynomial and then decide if it is a monomial. So here, this one is not a polynomial at all. So it's not a monomial. It's not a monomial. Next, binomial. Binomial. So a polynomial with two non-zero terms. So 0 plus 0 is not a binomial. Or say like x plus 0 is not a binomial. X plus 0 is not a binomial. A polynomial with two non-zero terms. No term should be 0. No term should be 0. A polynomial with two non-zero terms is called a binomial. Is called a binomial. So neither of the two terms must be 0. As I was telling you, xy plus 0. No, it's not a binomial. Xy plus 0 is a monomial. Xy plus 0 is a monomial because plus 0, you understand what plus 0, you can as well remove it. So xy is a monomial. Xy is a polynomial and xy is a monomial. It's like saying it is an animal and it is a dog. If it's not an animal, then how can it be a dog or a cat or any animal? If you're calling something, you look at a picture and say it's a tiger, and somebody says it's not an animal at all, then how can it be a tiger? It has to be an animal first. Only then you can call it a tiger. Similarly, it has to be a polynomial in the first place. Only then you can call it a monomial or a binomial or a trinomial. So polynomial is like animal, and monomial, binomial, trinomial are like cats, dogs, elephants, tigers. So a polynomial with two non-zero terms is called a binomial. Examples like x squared plus y cubed. X squared plus y cubed is a binomial of degree what? Of degree what?
3, ma'am.
3 is a binomial of degree 3. You should not add 2 and 3 here. X square is one term. Y cube is a different term. In the term x square, the power is 2. In the term y cube, the power is 3. The highest power is 3. So the degree is 3. So the degree is 3. So please write the definition and write x square plus y cube is an example, and continue. Say that if you have to describe x square plus y cube, it is a binomial of degree 3. Write down. It's a binomial of degree 3. Binomial of degree 3. X square plus y cubed is a binomial of degree 3. Done, children?
Yes, ma'am.
Yes, ma'am.
All right, children. Now, what about x square y cubed z plus 7? Is this a binomial? Do you find any zero term here? Is anything zero here? No. Okay, there is no zero. So x square y cube z is one term, 7 is the other term, because these two are separated. Okay, let me make it minus. It need not always be plus. Okay, so it can be minus also. Plus or minus, that is a separator. Plus or minus is a separator. So x square y cube z minus 7 is a binomial because two terms. X square y cube z is one term, 7 is the other term. The separator is minus. Separator, plus minus sign is a separator. It is a binomial because there is no zero term. If I say minus 0, take away that minus 0, it's only a monomial. Now tell me the degree of this binomial. What is the degree? Now this is another example. Please write neatly. This is another example, children. X square y cube z minus 7 is another example of a binomial. What is the degree?
3, ma'am. 3, ma'am.
Yeah, I'm just waiting for all of them to contribute their answers.
3, ma'am. 3, ma'am. 3, ma'am.
So shows all of you are very friendly.
4.
You're leaving me aside because I have a different answer. So nobody is, like on my side. All of you form one team and I'm left alone.
I'm 6, ma'am.
Who is that?
Rajat.
Very good.
Thank you.
Rajat alone on my side. Okay. Now think about it, children. Is it 6? See, your side may be correct. Prajit and I could be wrong. Yeah. Is it 6 or 3?
Ma'am, I think it's 3 because there are 2 terms and it's a binomial.
What's your reason? You
Because
think it
it's a
is 3
binomial.
because
It's a
it's
binomial.
a binomial. But x square y cube, that is one term, right?
Yes, ma'am.
Now, how do you pick 3 from it? Because that's the highest power, is it?
Yes, ma'am.
Highest power is selected between 2 terms, not within one term.
Yes, ma'am, I get it.
Class, so let me make it clear. X square y cube z minus 7. Do you all agree that it's a binomial? Let me come from there. Is it a binomial? All of you understand that? Any doubt there?
No.
All of you understand, all of you agree that it's a binomial. Now, how to decide the degree? How to decide the degree? Take up every term. Take up every term. All right. And what should you do? In every term, there may be one or more variables. In every term, there may be one variable or more than one variable. So look at every term. Look at the variables. And within that term, if there is more than one variable, find the sum of the powers of the variables. So here, this is one term. X square y cube, that is one term. And there are 3 variables x, y, and z. What do we do with the powers? Add the powers. 2 plus 3, 5. 5 plus 1, 6. 7 is a constant. 7 is a constant. There is no variable attached to it. Later we'll understand something more about that. But for now, this is enough. So 7 does not have any variable attached with it. So you don't have to find any power there. So in the first term, x square y cube z, 2 plus 3 plus 1, 6. 6. And there is no comparison at all. That highest power is also 6. Okay, let me make it like, say, x here. Okay, minus 7x. So here it is 2 plus 3, 5, 5 plus 1, 6. Here x, the power is 1. So 6 and 1, compare 6 and 1, which is the highest power? 6. So this one is a binomial. This one is a binomial of degree 6 in 3 variables. See, you can say so much. In 3 variables, x, y, and z. In 3 variables, x, y, and z. It's a binomial. It's a polynomial of degree 6. And it is a polynomial in 3 variables, x, y, and z. So write down the first example, x squared plus y cubed. There you should not add 2 plus 3 because x squared is one term. X squared is one term. This is one term. And in this term, there is only one variable x and its power is 2. So it's 2 here. And here in this one, there's only one variable, that's y, and its power is 3. So 3. Now, between 2 and 3, 3 is the highest number. 3 is greater than 2. So the degree of this binomial is 3. We'll take another example, children. I think with that, it should become clear. Have you all written this?
Yes, ma'am.
Okay. Can I clear the slide?
Yes, ma'am. Yes, ma'am.
Okay, I'm continuing with examples of, binomials. We'll just take another example. Now, supposing x cubed y plus 5 x minus say z to the power 3, xyz here. Oh, this is not a binomial then. Okay. We take away this. Yeah. Is it the binomial? Okay, let me just add a y here. Is it the binomial?
Yes, ma'am.
Yes, ma'am.
Because this is one term and this is the other term separated by a plus sign. So this is a binomial. This is a binomial. It is a polynomial. When you look at it, you should decide that. Yeah, the powers of all the variables are whole numbers. X to the power 3, y 1. Look at the powers. Look at the powers of all the variables. They're all whole numbers. So it is a polynomial. It is a polynomial. It is a polynomial. Look at the powers of all the variables. All are whole numbers. So it's a polynomial and it's a binomial because it is a polynomial. It's a binomial because there are two terms. Now the degree of this binomial. What's the degree of this binomial? Sorry?
5.
5, ma'am.
5.
5.
5. Tanishka?
Yes, ma'am.
Yeah, how do we find the degree?
And x cube 3 and y 1 and z 1, we have to add all the powers, we will get 5.
Okay. Then here,
For 5, there is 1, ma'am.
for 5, there is 1. No? 5 is raised to the power 1.
No, ma'am, for x 1 and for y 1, so 2, ma'am.
Which is bigger here?
5, ma'am.
5. So the degree is
5, ma'am.
5. You understand that clearly, Tanishka?
Yes, ma'am.
Okay, very good. So this one is an example of a binomial of degree 5. So within the terms, if you have, within one term, if you have more than one variable, then you should add the powers. 3 plus 1, 4 plus 4 plus 1, 5. Here 1 plus 1, 2. Now compare these two, whichever is greater. So the degree of this binomial is 5. What is the degree of this polynomial? What is the degree of this polynomial?
1.
1.
1.
1, ma'am.
1, because this is one term. This is one term. Power is 1. This is another term. Its power is 1. You should not add these two. This is one term. Power is 1. This is the second term. Power 1. This is the third term. Its power is 1. This is a constant. Ignore it. So now compare. All equal. So the degree is 1. The degree is 1. Yep. Make a note of this one. This is an example of a binomial of degree 5. You must write that. Binomial. This is an example of a binomial of degree 5.
Completed, ma'am.
Next, trinomial. Trinomial. Next definition, trinomial. Trinomial. A polynomial. A polynomial containing or having, okay, a polynomial with, you can write a polynomial with or a polynomial containing, a polynomial having. So I don't know what I wrote earlier. So whatever, a polynomial containing 3 non-zero terms, 3 non-zero terms is called a trinomial. It's called a trinomial. 3 non-zero terms. Nobody should be 0. So xy plus yz plus xz. This is a trinomial.
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
It is a trinomial of degree
2, ma'am.
degree 2 because 1 plus 1 2, 1 plus 1 2, 1 plus 1 2. Everywhere it's 2. So the degree is 2. Trinomial of degree 2. Is this a trinomial?
Yes, ma'am.
Yes, ma'am.
Is this a trinomial?
No, ma'am.
Why?
Yes, ma'am.
Yes, ma'am. It's trinomial, ma'am.
This is a trinomial, right?
Yes, ma'am.
Yes, ma'am.
It's not a trinomial. It's not a trinomial. Then this is a trinomial. 1 plus 2 plus 3. This is a trinomial.
No, ma'am.
So whenever you can simplify, you must simplify and then comment. This is not a trinomial.
Huh?
What I've written there is not a trinomial because you should simplify. Wherever possible, you should simplify. Oh, sorry, Z plus 12. This is a binomial. This one, now I'm not joking. This one is not a trinomial. This one, children, this one is not a trinomial. It is not a trinomial.
Yes, ma'am.
When you
Sorry.
can simplify, you should first simplify and then give your comment. So on simplifying, we get whatever x to the power 5, y to the power 5, z plus 12. It's a further simplification is not possible. It is a binomial of degree
11.
11. In
11, ma'am.
in how do you complete? In
Binomial.
Binomial, ma'am. Binomial, ma'am.
no. It is a binomial of degree 11 in 3 variables x, y, z. In 3 variables x, y, z. It is a binomial in 3 variables x, y, z of degree 11. So don't write this under the example of a trinomial. I was just trying to tell you. Now see here, is this a trinomial? Is this a trinomial?
No, ma'am.
No, ma'am.
No, ma'am.
No, ma'am.
No, ma'am.
It's 13x, ma'am. It's a monomial.
Yes, ma'am. 30 next, ma'am.
You should simplify. 5x plus 7x is 12x and 12x plus x is 13x. What is 13x? It's a monomial of degree 1. So everywhere, wherever possible, you must first simplify. Every time you must first simplify and then you should, conclude. You can make a note of all this, children. See, they are not examples of trinomials, but you can make a note of these situations. You must write somewhere that we should always simplify and then conclude. Always simplify and then conclude. In your own words, please make a note of all this. So 5x plus 7x plus x is not a trinomial. On simplifying, it is just 13x, which is a monomial. of degree 1 in one variable x. Are things clear, children?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Any questions? Please feel free to ask. Yeah, we'll move ahead. Let's write a few more examples of trinomials. So you will be asked to write, examples of trinomial of this degree in so many variables. You should know how to write them. Write an example of a trinomial of degree 100. Okay, tell me now. Give me an example of a trinomial of degree 100. Give an example of a trinomial.
Ma'am.
Trinomial of degree 100. Of degree 100.
Ma'am, x to the power 25 plus y to the power 25 plus z to the power 50.
50 plus xy.
Plus z to the power 50.
Very good.
Thank you, ma'am.
Okay. Just getting a call, children. Just 1 minute. Yeah, thank you, children. Yes. So this was from Pradit. This example was from Pradit. Another example.
Ma'am, A power 50 plus BC power 49 plus D.
A power 50 plus
Plus
B power
BC 49 per 49 plus D.
D. Is this of degree 100? I haven't still given my comment. I've just written whatever you people have, told me I've written.
Ma'am, x power 100 plus y plus z.
Rajat, this was from you, right?
Yes, ma'am.
And this is from
Ma'am,
Netra.
Madhumati. Ma'am, x power 100 plus y plus z.
Sorry, 1 minute. Write them again. Yeah, class, use the emoji, raise your hand. Netra, Prajit, Sanjay, Sindhu, Krishmi, Madhumita, Krishmika, Danya, Devadarshi, Jayan, Tanishka, Srijana and Vishant. Okay, Vishant is there, I can see him. Srijana. Okay, you're also there, fine.
Yeah.
All right, yeah. Disable your mic, yeah.
Ma'am,
Yeah, who's that?
ma'am, Sanjay. Ma'am.
Yes, Sanjay.
Ma'am, the highest power is only
1 minute. We are going to discuss. That's what I'm going to ask. I'm going to ask Danya first. Danya,
Ma'am,
yeah, I want your comment on Prajit's example. 1 minute. I'm very sorry. Yeah, so Prajit said x power
25, ma'am.
25 plus y power 25 plus z power 50. Do you agree with Prajit? Then just say yes or no. I don't want justification now. I'll ask you later. You agree with Prajit? Yes, no. Is this a trinomial? Is this a trinomial of degree 100? That's what we're discussing. Trinomial of degree 100. Yes, quickly, Danya. You shouldn't take this much time. Yes, or no? Yes. So she agrees. Now, next, very good. You have some one person to support you, Prajit. Okay. Now, Netra's example. No, you can't go back on your example, Prajit. No, you can't go back on your example now. You're late. And now, who's that? Netra. Netra, what was your example? A to the power 50 plus B to the power 49 plus D. Yes. Sanjay, do you agree with Netra's example?
Ma'am, no.
Yes or no?
No, ma'am.
Simply you're saying no because this one No, yes only. You want to say yes, right?
Miss, ma'am, no, ma'am. No, ma'am.
But you have a reason for that.
Ma'am, because we can't add the powers right now.
Hindu, is it?
Yes, ma'am. So only no.
Yeah, now Prajit, tell me. Prajit, you're wrong, right?
Yes, I'm wrong, ma'am.
Yeah. Okay. Now, Prajit, is this a trinomial?
Yes, ma'am.
Of degree?
50.
50. Netra, is this a trinomial?
Yes, ma'am.
Of degree?
100.
Of degree 100?
Yes, ma'am.
Ma'am, degree is the highest power of the variable, ma'am.
Yes, ma'am. The answer is 50, ma'am.
Degree 50, ma'am.
50, ma'am.
No, Netra is not happy with me. Why, Netra? How can you add the powers here? This is one term. The power is 50. This is another term. How can you add the powers of two different terms? This one is 49. And here the power is 1. The highest power is 50. So the degree is 50. If it was 8, if you had given this one is not a trinomial, but if it is a power 50, b power 49, d, this one is a monomial of degree 100. Here you can add 50 plus 49 plus 1.
Okay, ma'am. I understood, ma'am. Got it.
This one is not a trinomial, but it is a monomial of degree 100. Here you can add 50 plus 49 plus 100. So we'll have to be very careful. Sometimes, yes, it is deceiving when you're asked, supposing you have to comment about the degree of this polynomial. Suddenly we'll feel, yeah, it is 100. But it is not 100. Be careful. It's only 50. So I think this is enough, no? We have understood.
Yes, ma'am.
Yeah. Monomial, binomial, trinomial. All these are polynomials. A monomial is a polynomial. A binomial is a polynomial. A trinomial is also a polynomial. What is a polynomial? An algebraic expression in which the variables involved have non-negative integral powers. That means whole numbers as their powers. So the powers of the variables must be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. It cannot be 1 by 2, 1 by 4, or negative. It cannot be a fraction because a fraction is not a whole number. The power cannot be 1 by 2 or 2 by 5, 3 by 7. No, it cannot be negative because that is also not a whole number. So the powers must be whole numbers. The powers must be whole numbers. A monomial is a polynomial. A binomial is a polynomial. A trinomial is also a polynomial. Danya, do you understand that example was wrong?
Yes, ma'am. Now I understand.
So that's about, what you just learned. You can just give this heading. These are polynomials. Polynomials based on the number of terms. Polynomials based on number of terms. Number of terms. Number of terms. 1 term, 2 terms. You can give this heading. Monomial, binomial, trinomial. These are polynomials based on number of terms. Not based on the degree. Based on the number of terms. Wrote the heading?
Yes, ma'am.
1 minute, ma'am.
What we just discussed are polynomials based on the number of terms. Yeah. Now we'll see, we'll understand what is meant by a constant. No, before that, we'll understand polynomials based on degree. Polynomials based on degree. Linear polynomial. Linear polynomial is a polynomial of degree 1. Of degree 1. A polynomial of degree 1 is called a linear polynomial. So now if I write example, a plus b plus c plus d plus e plus f plus 100. This one is a linear polynomial. It can have any number of terms because don't get, this one is not, we are not talking about monomial, binomial or trinomial. We are talking about a linear polynomial. It can have any number of terms. It can have 1 term, 2 terms, 5 terms, 10 terms. Linear means the degree should be 1. Linear polynomial means the degree should be 1. It can have any number of terms. If you are asked to write a linear polynomial with only 1 term, then you have to, stick to that instruction and give an example. In general, when we say linear polynomial, it is irrespective of the number of terms. When we say linear polynomial, we are only talking about the degree. We are not talking about the number of terms it should have. It can have any number of terms. The degree should be 1. But if you're asked to give an example of a linear polynomial with 2 terms, then you should give an example of a linear polynomial with 2 terms. Okay, so here this example is, this one is an example of a linear polynomial. No jokes. This one is an example of a linear polynomial. Because what's the power 1? 1, 1, 1, 1, 1. Now you should not add these powers because they're all of different terms.
Yes, ma'am.
You should not add here. You must not add the powers. Yes or no?
Yes, ma'am.
You should not add the powers.
Yes, ma'am.
So the highest power is 1. So it is a linear polynomial in 6 variables. In 6 variables, there are 6 different variables. And there are 7 terms. There are 7 terms, 6 variables. Degree is 1, linear polynomial. Then quadratic polynomial. So you can, if you want a few more examples. So now tell me, do not write this. Just tell me, is this a linear polynomial?
Yes, ma'am. Yes, ma'am. No, ma'am. The degree is 4, ma'am.
No, ma'am.
Degree 4, ma'am.
It is a monomial of degree 4. It's a monomial of degree 4. 1, 1, 1, 1. One term it is. It's a monomial. It's one term. It's a monomial, but of degree 4. It is not a linear polynomial. It is not a linear polynomial.
Yes, ma'am.
No doubt there, children?
No, ma'am.
No, ma'am.
Krishmika Shri is very quiet. Krishmika Shri, are you following?
Yes, ma'am.
Clear, very clear?
Yes, ma'am.
Yes. Now what we will, yeah, linear polynomial. So linear polynomial, is this a linear polynomial? 5x plus y plus z square. Is this a linear polynomial?
No, ma'am.
No, ma'am.
No, it is not linear.
No, ma'am.
No,
Because
ma'am.
this is 1, this is 1, this is 2, this is 2. So it's quadratic. And based on number of terms, what is it? It is a, based on number of terms, it is a
Trinomial.
Based on number of terms, it's a trinomial. Based on number of terms, it has 3 terms. So it's a trinomial. Degree is 2. Number of variables 3. Number of variables 3, x, y, z. Degree 2. Trinomial. Finish writing?
Yes, ma'am. Yes, ma'am.
So that was about a linear polynomial. Second, quadratic polynomial. Quadratic polynomial. New students, Lishant and Srijana, are you all writing this down on your book? Everything from your screen?
Yes, miss. Yes, miss.
Okay. Yeah, quadratic polynomial. Quadratic polynomial is a polynomial of degree 2. Is a polynomial of degree 2. Of degree 2. Is a polynomial of degree 2. So it can have any number of terms. It's a quadratic polynomial of degree 2. It can have any number of terms. Example, 55x square plus x plus 7. Is this a quadratic polynomial?
Yes, ma'am.
Yes, ma'am.
It is a quadratic polynomial. Yeah, it is a quadratic polynomial because the power of x here is 2. The power of x here is 1. And the highest power is 2. The highest power is 2.
Yes, ma'am.
Is this a quadratic polynomial? Is this a quadratic polynomial? This one is a quadratic polynomial. Is this a quadratic polynomial?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
This project, you're not sure.
Yes, ma'am. I'm thinking.
Yeah, think. Important.
ஏய் ஆனா அறிவு இருக்கா நான் கோயிலுக்கு போகணுங்கிறேன்.
Okay, Rishan, disable your mic. Yeah. Where are you, Rishan? Yes, think and tell me. A square plus b plus root 5. Is it a polynomial?
That's what I have a doubt in.
Yeah, even I. Is it a polynomial? Because we are saying quadratic polynomial. We are saying quadratic polynomial. So it should first be a polynomial.
No, ma'am, it's not a polynomial. It's not a polynomial. Yes.
Why
It's not a
some of
polynomial.
us don't want to participate? You want to give the correct answer always, is it? So when you're not sure, some of us are like, it's better not to say anything. Is this a polynomial or not?
No, ma'am, it's not, ma'am.
It is
No,
not.
ma'am.
I have not. I don't know. Yes, I can see.
It is not a
Sanjay-
polynomial.
Yeah. So I can see Krishmika Shri. What do you feel? Is it a polynomial?
No, ma'am. It is not a
Tanya?
polynomial. Ma'am, I'm a bit confused, ma'am. Why, ma'am, it's not a polynomial?
Okay, Sanjay and Sindhu.
I have the same doubt, ma'am. Why is it not a polynomial?
Ma'am, we also have the same doubt, ma'am.
Root
Yes,
5.
ma'am.
ma'am.
I'm also having the same
See,
doubt.
Project is answering root 5. That's why.
Ma'am, but in the name itself, it's given quadratic polynomial.
Correct. No. What is that, Sindhu? Yes.
Ma'am, because of the root, it is not a polynomial, ma'am.
Because the power is half, 1 by 2, right?
Yes, ma'am, it should be, the power should be a whole number.
No, don't write anything now. We haven't still concluded. Don't write anything now. Yeah. Others? Okay, we all have a doubt. Let us get that doubt clarified. So what is the definition of a polynomial? It's all there in the definition. There is nothing like, in this situation, it is like this. In that situation, it's like that. No, the definition tells you everything clearly. Go back to the definition. A polynomial is an algebraic expression in which the variables involved, not this one. This one is not a variable.
It's a irrational
5
number.
to the power 1 by 2 is a constant. The constant can be anything. The powers of the variables involved must be whole numbers. See, am I saying anything? The definition is saying that. So there is nothing to get confused. A polynomial is an algebraic expression in which the variables involved, understand every word in the definition, in which the variables involved have non-negative integral powers. So the variables must have whole numbers as powers. The variables must have whole numbers as powers. Now the variable here is A. The power is a whole number 2. The next variable is B and its power is 1. It is a whole number. This one is a constant. Root 5 is a constant. It has some fixed value. It's a constant. Don't worry about that. Powers of the variables, are they whole numbers? Now tell me. A square plus B plus root 5. Is it a polynomial or not?
No, ma'am.
No, ma'am. No, ma'am. It is not a polynomial.
My God.
Ma'am, it's a polynomial, ma'am.
No, I can't explain this now. Some student has to say. No. Who says it is a polynomial?
Ma'am, Sanjay.
Who says it's a polynomial?
Ma'am, Sanjay, ma'am.
Sanjay, tell the class why is it a polynomial, Sanjay?
Ma'am, because the variable a and b have a whole number power, ma'am. For a it's 2 the whole number power, and for b it's 1 the whole number power, ma'am. The constant that doesn't come inside the how deciding it's polynomial or not.
Yeah, the constant has no role in deciding if it's a polynomial or not. The constant has no role at all in deciding if it is a polynomial or not. The role is given only to the variables. Look at the variables and their powers. Are they whole numbers?
Yes, ma'am.
Yes,
What
ma'am.
class? After listening to all this, they're saying, no, it's not a polynomial. 1 minute, wait.
It is a polynomial.
Let me write the definition of a. What is a polynomial? Now, at the end of the discussion, we are going back. We are going to the start now. A polynomial. What is a polynomial? An algebraic expression. An algebraic expression in which the variables involved have variables involved, not constants involved. Variables involved have non-negative integral powers. The meaning of this phrase non-negative integral powers means whole number powers. Whole number as powers. The meaning of this. That means the power can be 0, it can be 1, it can be 2, it can be 3, it can be 4, 5, 6, 7, 8, 9. The power should not be a fraction. The power should not be negative. The power should not be a fraction. The power cannot be negative. It should be only whole numbers. Absorb the definition in your mind first. All right. Can I clear the slide?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
You students, Lishant and Jana, have you written this?
Yes, ma'am.
So we were talking about a square, whatever, b plus root 5. It is a polynomial. Whole number.
Quadratic polynomial.
It is also a whole number. One is a whole number. This one is not at all considered in deciding if it's a polynomial or not. So a square plus b plus root 5 is a polynomial of degree 2. This one is a polynomial of degree 2. It is a quadratic polynomial. And based on number of terms, it's a trinomial. Based on number of terms, it is a trinomial. There are 3 terms. It's a trinomial. Based on number of terms, it's a trinomial. Okay, the next one. Next one is a cubic polynomial. Cubic Cubic polynomial. Cubic polynomial is a polynomial of degree 3. So this one is a cubic polynomial. This one is a cubic polynomial. It is a monomial. That is different. Monomial is based on number of terms. That classification is different. This is based on degree. Degree is 3. 1 plus 1 plus 1 is 3. So this one is a monomial. It is a cubic polynomial in 3 variables x, y, and z. Example is x, y, z, children, x, y, z, or x cubed plus y plus, like something like root 7. Yes?
Yes, ma'am.
XYZ is a cubic polynomial because the degree is 3. The degree is 3. 1 plus 1 plus 1, 3. It is a cubic polynomial because its degree is 3. And this one also is a cubic polynomial. The next one is also a cubic polynomial. Degree is 3. This one is a monomial. This one is a trinomial. Now tell me if this is a cubic polynomial. Is this a cubic polynomial?
I think yes.
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Now,
Yes,
you
ma'am.
should not say I think. I don't want that answer. You
ma'am.
should be sure.
Yes, ma'am. Yes, ma'am.
Then when
Yes,
will we
ma'am.
understand clearly?
Awesome.
We should say it is a cubic polynomial or it is not. For both, you should be able to justify. You say yes or no. Don't stand in between yes and no.
Yes, ma'am. Yes, ma'am. Yes, ma'am.
If it is yes, you should justify. If it is no, you justify.
I mean, it's because 3 is the highest polynomial value, degree, ma'am. 3 is the highest degree, ma'am.
Yeah. Back to the class. Danya, Tanishka, Krishmika, Shri, Lishant, Netra, Devadarshini, Sanjay, Sindhu, tell me. Rajit, Adamita, Krishmi. All of you agree?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
What if I say no? I am wrong or you are
Actually,
wrong?
no, because z is a variable, ma'am. Because z is a variable, it cannot be a polynomial, ma'am.
Reason.
Yes, ma'am, because z is a variable, and according to the definition, it's not possible, ma'am.
Why?
Because only constants. If it was root 5, if it was a constant, then we can consider it a polynomial. But
You've understood, but you're not able to express. No, you should use something else. You must say z is a variable, correct? So what do you want to say about z?
ma'am, its power is 1/2, which is not a whole number, ma'am.
Yeah, that's what you must say. Its power is 1/2 and it's not a whole number. So this is only an algebraic expression. It's not a polynomial. Then how can you call it a cubic polynomial? It's not a polynomial at all. X cubed plus y squared plus root z is not a polynomial at all in the first place. Because z is a variable and the power of z is 1/2. Root z means z to the power 1/2. Root z means z to the power 1/2. Root z means z to the power 1/2. Z is a variable. So we are interested in the power of the variable. It's 1/2. It's not a whole number. So this one is only an algebraic expression. It is not a polynomial. If it is not a polynomial, how can you call it a cubic polynomial? Are we using the definition strictly?
Yes, ma'am. Yeah.
Yeah, we are using the definition strictly. There is nothing to get confused. As per the definition, if you want to call an algebraic expression a polynomial, all the variables must have whole numbers as powers. Now here z is a variable. What is its power? 1 by 2. Is it a whole number? No. Then it's not a polynomial. Then how can it be a cubic polynomial? So this one is not, it's just an algebraic expression. Nothing more than that you can say. It is just an algebraic expression. It is an algebraic expression. So as somebody said, instead of root z, if it was like root 11, that is fine. 11 is not a variable. It's a constant, meaning root 11 is a constant. So it is a cubic polynomial. If it is root 11, it is a cubic polynomial. If it is root z, it is not a cubic polynomial because it is not a polynomial. Yes, make a note of all that in your own words.
Yes, ma'am.
Yeah, we need to discuss two more terms quickly. Yeah.
Finish.
Yeah. Now next is a constant polynomial. Constant polynomial. Constant polynomial. Every non-zero, that means other than zero, every non-zero real number, that means a number that exists. Real number meaning numbers that exist. There are imaginary numbers, numbers that don't exist, that you will learn in standard 11 and 12. So every non-zero real number. So we will be talking only about real numbers, numbers that exist, rationals and irrationals. Every non-zero real number is called a constant polynomial. Not zero. Every non-zero real number. Zero is not a constant polynomial. Zero is not a constant polynomial. Every non-zero real number is a constant polynomial. Constant polynomial. When we say real number, it can be rational or irrational. Can be rational or irrational. It should not be zero. Zero is also a real number. Zero is also a real number. So a constant polynomial is every non-zero real number. Other than zero, every rational and irrational. Got that?
Yes, ma'am.
Yes, ma'am.
Yeah. So like say root 5 is a constant polynomial. Is a constant polynomial. 3 is a constant. 3 is a constant polynomial. Minus 5 is a constant polynomial.
But that's no variable.
Somebody's.
I asked that's no variable.
Yes, Project, you have a question?
Yes, ma'am, that's no variable as x or y.
If it has a variable as x, you're asking 3x, is it?
Yes, ma'am.
This is not a constant polynomial. This is not a constant polynomial. It should be a constant. A constant meaning any real number, but not zero. 3x is not a constant polynomial.
Yes, ma'am.
3x is not a constant polynomial. A constant polynomial is any real number other than zero. Other than zero, every real number is a constant polynomial. Every real number, all real numbers, that means all rational numbers, all irrational numbers are constant polynomials, except zero. Now, what is the degree of a constant polynomial? What is the degree of a constant polynomial? We studied about linear polynomial whose degree is 1, quadratic polynomial whose degree is 2, then a cubic polynomial whose degree is 3. I think we don't have time. Oh, I forgot to mention biquadratic. Make a note, biquadratic polynomial is a polynomial of degree 4. Yes?
But in our school they told quartic is the name for degree 4, ma'am. Polynomial with degree 4, ma'am.
No, I can't get you.
Ma'am, in my school they told for polynomial with degree 4 it is quartic polynomial, ma'am.
Yeah, there are different names.
They told biquadratic is not the correct term, ma'am.
Oh, really?
Yeah, ma'am, I got confused with that.
Okay, which other school you got this? You have not come across the term biquadratic?
Ma'am, they taught us biquadratic
We
polynomial.
also taught ourselves.
For us also biquadratic only, ma'am.
Okay, don't worry. What are your name? Sanjay and Sindhu, go ahead with the term your teacher has used. Follow what your teacher says. Yeah, both are the same. Biquadratic is also a polynomial of degree 4. Children, we need to discuss, constant and zero polynomial. We need to, because this is very important, we need to discuss about their degree and the number of zeros. Number of zeros and degree, I think we'll take it up in the next class. I'll just give the definition now. We'll just take it up in the next class. Constant polynomial, or if you understood right, every real number, all real numbers are constant polynomials other than 0, not 0. Other than 0, all real numbers are constant polynomials. Constant polynomials will not have any variable in them. X, Y, Z, no. All real numbers, not 0, are constant polynomials. And what is it now? The last one, a zero polynomial. A zero polynomial. Zero polynomial. Zero is the only zero polynomial. Sorry. Zero polynomial. The real number 0. The real number 0 is called the zero polynomial. Only 0. 0 is called the zero polynomial. The real number 0 is called the real zero polynomial. Because in constant polynomial, it is not included. In constant polynomial, it is not included. All right. A constant polynomial does not include 0. 0 has a special name. 0 is the zero polynomial. 0 is the zero polynomial. So there is no example of a zero polynomial. Only 0 is called the zero polynomial. You cannot write examples of zero polynomials. 0, the real number 0, this one alone is called the zero polynomial. Other than this, all the other real numbers are constant polynomials. Biquadratic, I forgot to write, is a polynomial of degree 4. Biquadratic polynomial is a polynomial of degree 4. So
Yes,
next class, remind me children, we need to discuss about the number of zeros, the degree. Next class, we need to discuss about degree of a constant polynomial.
I know that.
Degree of a zero polynomial. Number of zeros of a constant polynomial. And the number of zeros of a zero polynomial, You see this in the next class, and then we'll continue with what we were doing in the previous class. I think we have to continue with question number 8. We finished 8 also, right, in the last class?
We have to start with 12, ma'am.
11,
we have to. We finished till 7, is it, in the last class?
We finished.
So, okay, we have to continue from here. So we'll do this in the next class. So remind me, we'll have to discuss this in the next class.
Okay, ma'am.
Yes, ma'am.
All right. All right, children.
Thank you, ma'am.
So that was it for today's session. Thank you so much. You may leave the
Thank you,
call.
ma'am.
Thank you.
Thank you,
Thank you,
ma'am.
ma'am.
Thank you, ma'am.
Thank you, children.